Real quickly, just to kind of hit on Hololens 2 is kind of a lead into Magic Leap. They're kind of sister technologies. And by the way, I've done like extensive evaluations, and this gets into the laser beam scanning process. If you want to know how that laser beam scanning works, what's wrong with it, what HoloLens did, I've got all that on my thing. And as I said, when I very first heard what their scan rate was, I knew they had failed. Alice Kipman, the one that everyone complained about, was he said it was 2x the field of view, when most people know field of view is measured linearly. He was talking area. By the way, now Magic Leap 2 is now talking area for field of view. They said, oh, that marketing gimmick worked for them. But Alex Kipman managed to make the news lately. Apparently, he was looking at was inappropriate content, let's just say, on his HoloLens 2 while talking to employees at the company. At least that's the story that went. He was very quickly after that removed from the company, and he was considered to have rather toxic behavior. I have not been a big fan of on my blog of Alex Kipman. He reminds me a little bit of bringing back Magic Leap into the story, a little bit like Ronnie Albovitz. He said things, and it's like, this is gibberish. It's gibberish, and he's talking stuff that sounds like he knows what he's doing. And to somebody who knows nothing about optics and displays, it may make even sound like he knows what he's doing. It's like if somebody was speaking a foreign language and you didn't know that language, and they started speaking with certain inflections and whatnot, and you'd think, oh, maybe they know that language. Well, it turns out if somebody can speak the language, they say he's talking gibberish.
Yeah.
That's kind of what's going on here. He talked about 47 pixels per degree. Well, I knew back from math that it failed the math, that it didn't have that resolution. But once I got one in my hands, I set out to prove it. This is a HoloLens 2 at 47 pixels per degree. It's a blurry mess.
Yeah.
You can't do it. So he says it's 47 pixels per degree. It's an important number to remember. I've got him on tape saying this on YouTube. Same thing. These are the smallest, most efficient 2K displays in existence. None of that's true. And they're not small either. They were huge.
Yeah.
So I've done a whole series on that. People know they're also famous for getting the IVAS program. That thing's been falling apart.
Yeah.
From what I hear, the military is trying to figure their way out of it. The bottom line is this was the one that my guys rolled on the floor over when they said the Army's futuristic new goggles are changing the mechanics of shooting according to soldiers. I work with Navy SEALs. Yeah. These guys thought this was rolling on the floor funny. Can you imagine wearing that in the desert on top of your helmet? And notice, this is a cloth. You don't even have a helmet on. You don't have any kind of ballistic protection at all. This is insanity. Plus, if a guy doesn't even need night vision to see you, you're lighting up the world with your front projection. This was never going to happen. One other thing while I've got this here, I threw this in at the last minute that Meta looks like they're backing up a bit.
Yeah.
The latest reports that Meta is no longer targeting consumers for 24. I'm kind of the industry skeptic, and it's hard to prove a negative. People say, oh, Meta's got all the money. I think Apple will keep slipping too. If they do, the problem is as I sometimes say, they got to land the plane.
Yeah. And
when they land the plane, it never quite meets the expectations of what people thought this big company can do. It turns out this problem is a lot harder than people think. So we won't get into all the waveguides and stuff. This is all on my blog. One thing I do want to just quickly mention, because this will tie into Magic Leap. As I said earlier, waveguides naturally, and this is whether they're Lumus or HoloLens, the light that goes in has to be focused at infinity. And therefore, the light that comes out is focused at infinity. What that means is if you want it to be 2 meters away, that's focused too far. It'll feel you'll get eye strain from that. Most glasses do about a half diopter, which tends to move it to about 2 meters. But if you do that, and you're looking through this lens to look at your waveguide, you have to then compensate, just so we talked about with freeform optics, you have to exactly equal and opposite compensate that with a half D lens to move that focus in. By the way, this comes into a problem. If you start to do varifocal lenses here, let's say we want to move the focus, so we want to move adaptive focus. guess what? You have to do it over here too, because you have to fix, if you move it over here, if you start fixing this focus, changing the focus of the display, because you're trying to move the display, you don't have to correct for the real world. Otherwise, you're going to be moving the focus of the real world and the display. It's a big problem. Now, one thing Magic Leap 1 did is they built the focus change into the output of the grating. They literally, you can, just like kind of holograms, you can design in here this change. Turns out the image quality suffers from doing it. It's not as good a way to, the light kind of breaks up and gets fuzzier and stuff. So this is one of the reasons why Magic Leap, when they did it, they put two different, actually had 6 gradings. So when you were looking out, you had 6 layers of grading. So this is just showing 1 layer, but actually to do red, green, blue, they needed 3 layers. What they did is they did 6 layers. So what they did was they put a different focus. They had 2 sets of 3, and they moved the focus on 3 of them. But the problem you have there is you had to look through 6 layers. The plane you used the most, the focus of 2-meter planes, were the furthest away. So the red layer was on the very outside. To look at red from in here, you had to look through 5 other waveguides to get to the red. And so that was really degrading their image quality. So one of the big secrets to Magic Leap 2 was to not do that. So now Magic Leap 2 looks almost exactly like HoloLens. They got rid of this grading in the output. They go to a single 3-layer waveguide, and then they put a lens on the front and the back of the waveguide. So that's kind of, and that's what we see happening. This is Magic Leap 2 thing. Like I say, you can go to my website. I'll show you why this is, I put up as good an image as ever been seen from HoloLens 2. It's a terrible mess. So I always say with HoloLens 2, it proves that image quality is unimportant for the applications it serves.
Yeah.
And we talk about the scanning process, and I'll flip through here. This is all coming from my website, so you can go to my blog and you can get all this stuff. By the way, he said it was small, too. It's like nothing that Kipman said was true. I have done a comparison to Lumus. Lumus is, as I said before, is probably the best quality thing I've seen. And once again, look at their engine. This is a 2K by 2K, 50-degree, full-color, much better quality image compared to what HoloLens did. And I say the effective resolution of HoloLens, in spite of what he said, I consider it about a 1280 by 854 display. That's about the effective resolution. It's really poor. And that's not counting how terrible the color looks. So now let's transition. We're transitioning over to Magic Leap. One of the big things I'm in is, what's your use model? The HoloLens 2 has just terrible image quality. It's just undeniably that it's crap image quality. However, when you're talking enterprise, they did do a few things right. They gave up on the fact this is going to be glasses. Notice how they're not supporting it off your nose. They're not supporting it off of your ears. Just can't be done. Not when you go to 50 degrees field of view. It's just, as soon as you go to 50 degrees field of view, everything's spiraled up too much. You've added too many different things to put it on your head. It's wireless. One thing they did neat, they moved, I call it the back bustle. They moved it to a bustle on the back. The electronics, everything you move to the back. That balances the front way so you're not tilting forward like you've had with all these glasses.
Yeah.
And you've moved as much weight. It balances out. It's a good place for it. You've got more room to put air. One of the things that if you go and look at some of the Microsoft videos and stuff they put out, they did a lot of work to make this thing where it had no fans, but by moving it over here, they're putting a lot of heat back there that they can radiate. And look at that big radiation area they have. And they've got holes up here. They got they got a little heat pipe. If you actually look at these are little things. So those are for heat. That's basically to suck heat through. It's like a passive fan.
Yeah.
They get heat out. Which tells you that this thing's not real low power either. It's consuming tons of, that power was a lie too. I mean, everything he said, nothing he said was probably true. They did a lot of ergonomically good things. Look how the eye is back here. You can wear glasses with it that has enough eye relief for glasses. Now that's lousy if you're trying to build glasses, but it's great if you're building an industrial product, an enterprise. Look at how the view out. They've got a good view out of it. This is from Bernard Kress, but he talks about, like with HoloLens, they've got a very good view out. Now he missed the fact, he said it was black down here, but actually you do get a little view out at the bottom of the Magic Leap 2. This has gotten worse on Magic Leap. I'm sorry, Magic Leap 1. This is Magic Leap 1. I don't have all the nice side comparisons. It's worse on Magic Leap 2. They've moved this thing, if anything, crammed it closer to the eye. But here's the thing. If you're in an industrial environment, this is machinery that could kill you.
Yeah.
This is what things you could run into. You can't, this is a bad model if you're talking industrial floors type stuff. Also, there's no cords. This is a snag hazard. The Magic Leap 2 had like a kind of a double cord. The new one has a single cord, same problem. You also got a problem when you have a cord on one side, it tends to make the whole thing swivel.
Yeah.
But anyway, so you're looking through this thing, there's just all kinds of things where you see they have eye relief, they have enough eye relief for glasses. That costs you. To make that eye relief means they don't get the, when this guy talks a bigger field of view, yeah, it's easier to do. The equivalent effort to make that eye relief, you can make a much bigger field of view. You've given up, you've knowingly traded eye relief or field of view to get a more eye relief. They go hand in hand with the same complexity. So part of what went into HoloLens was giving you that eye relief. They just said, oh, we made a different design decision. We're going to have clip-in things, and we're going to move it so close to your eye that you can't see out. So it's a different set of trade-offs. It's not the same. By the way, I don't know what happened to the Nreal Enterprise Edition, but Nreal basically made a kind of a baby version of HoloLens 2. Although I don't think they put the bustle on the back. My first comment to them was, you ought to put the electronics on the back, not in a separate wire. I don't know how they were going to bring it out, but you would like to put all your electronics in the back and balance it out. So on the that's kind of a transitional into Magic Leap 2. I did get to try one on. Here's me at the show, wearing the Magic Leap 2. I can't. I only got to have 2 5-minute demos. Plus, I got a very nice side visit where they took me off and let me see the dimming, the auto dimming, and we'll talk about that in a little bit. Here I am wearing them. You'll notice it's still front projecting. We're still doing the front projection stuff, so I haven't solved that. I will say the image quality is just vastly better. It's hard to know. Once again, I got 2 5-minute demos to evaluate the image quality.
Right.
Very canned demos. It felt to me like it was, and I've had other people say it's very spotlight. It was like the center was a lot brighter than the outside. It's hard to know that unless I can control the content and have more time with it and really, like when I did those HoloLens evaluations, that was over 2 weeks of work.
Right.
Taking pictures, taking it off, putting my own content on it. It takes a lot of time. You can't do that on a show floor. I didn't even try.
Yeah.
I will say the image quality for a diffractive waveguide looked about as good as I've ever seen, from what I could tell. Okay, I was looking. They had a scene there that was looking at a fairly gray-looking image, and I didn't see a lot of rainbowy color and all. Not to say it doesn't exist. Once again, one time, 5 minutes, not a lot of good content, not content that I could control and do.
Yeah.
It definitely looked it did look like it had the resolution. They're using LCOS. They're using, I believe it's Omnivision's LCOS. They're a company out in California. But anyway, that's their booth. Their booth was very busy. Nicely, as I said, I used my strategy of, well, actually, I was actually showing somebody else the booth when they recognized me and skirted me off for a private demo, which is nice of them because they know I'm not their biggest fan. But I think they're. I mean, the rumor on the street is Magic Leap is trying to be bought. The word is, I don't know how people hear these things, but I heard from several people that Meta had visited them and decided not to buy. The problem they have is that they're $3 billion. By the way, I have a new unit of measure for expenses. Meta is spending almost a Magic Leap a quarter.
Yeah.
A Magic Leap, but it was funny when I go up to the VP at the prior conference in SPIE, and he said, "Yeah, we're one of the little guys," and I'm like, "Little guy? You've got $3 billion." He says, "Yeah, but look at we're talking Apple and Facebook and stuff."
Yeah.
They went through a process, and this goes back to this is from their own slides. They looked at micro LEDs, they looked at laser scanning, They said they spent millions on trying to do it and could not solve the scan line problems. They actually started with wiggling scanning. And this is the irony, because their two big things were to do two focus depths and to use what they call a wiggling fiber laser. It was a laser scanning, but with a wiggling fiber, which I've got a big thing on my blog where I said that was never going to happen. They said, look, micro LEDs are not ready, as we've talked about. I think they could be 5 or 10 years away from being ready. There's some interesting stuff being done. It's not that you don't have smart people on it, but they're a long way from putting one really good unit in your hand. And once they do that, then you got to put 1,000 units in your hand and then 10,000 units in your hand. And each one of those things is like, it's like take some effort you put to get to the first unit, getting the 10,000 units might be more effort than that.
Yeah.
And then getting to 1 million units is more effort than those two put together. That's kind of the way it goes. But anyway, in the end, they went back to LCOS. They stayed with LCOS, which I think is what HoloLens 2 should have been. I think HoloLens 2 would have saved hundreds, literally, I think they spent hundreds of millions of dollars trying to make laser beam scanning work. What they did do is they hired a bunch of people from Microvision and probably made them wealthy due to their stock options. It's really classic. You buy this expertise, and they convince you to use their old company's product that they have stock options in, and it was good for them, but it made the stock bubble up really high. Let's look at Magic Leap 1 versus 2. So we got 2 on the left. If anything, they kind of just they thinned it out, they shrunk it down. If you want a big field of view and a smaller thing, you got to keep moving it closer to the eye. What they've done is the clip-ins, where you clip the lenses in, are now more embedded in. So they had to move the clip-in optics. If you're going to use vision correction, they had to move that even closer into the thing because there's not as much room. I was there with Jason McDowell, and he's actually the one who commented on that. He does the AR show. Excellent podcast, by the way. He asked a great question. I've been on it a couple of times. But I was with him, and he commented, and it's true. You really, if you take your finger like this, that's about your view out. That's all you get. Everything else is blocked off. There's very little view out now with this thing. And so that may make the image look better because now you don't have, but you're really almost VR. The other big problem, and I'll talk more about this, is that it's now it's 20% light throughput. In other words, thanks to everything else they've been doing, the basic light throughput. So you blocked off all of this light, and the light you can see in the real world, you're only seeing 20% of it.
Yeah.
Best case. That's before we do all this dimming stuff. Still with the cord, instead of having 2 cables coming out, and it's still wired in as best I could see. That's insane. I don't know any safety officer is going to let them get away with that. Because this thing is going to, if this thing gets caught in something, it's going to rip this thing, take your head with it. I don't know if the whole thing breaks apart or what. It's certainly going to break the unit and may cause you damage. I just think this is unconscionable. This is at least wireless.
Yeah.
One thing I'll give the HoloLens too, it's certainly the easiest to just take out and put on. By the way, they now include a case with it. My Magic Leaps sit in a cardboard box with foam around them because they didn't give you a case. They now give you a case. The case is smaller, but I used to joke that when these things are supposed to be portable,
yeah,
by the time you protect this thing, the case, I always say you can fit about 2 of them in a rollerboard, in an overnight a classic rollerboard. You hold 2 of them. They're not portable in the sense you put it in your pocket when you take it off. Now, they're portable in the sense that you can put it in your backpack when you take it off. It's not exactly what I think of as portable. Anyway, they've done a lot to shrink it down and improve it. The image quality is definitely a lot better. The field of view is better. People be fairly happy. It's still, by your standards, a trivial field of view. It's about 70 degrees, give or take. Once again, you still got a cord going to this puck. I thought it was bigger, but it's more psychological. It's about the same size. The computer puck, or whatever you want to call that, thing's about the same size. They're big new feet. I believe the resolution's what it is. It's field sequential color. It looks good. It still has the rainbow effect. I don't know what their field sequential rate, but if you move your head around, you'll still see some color breakup.
Yeah.
There are some tricks to solve that. I know Tilt 5 does some tricks with head tracking to try to reduce that. It is a complicated as hell set of optics, though. There's a lot of optics between, a lot of layers of stuff between the world and your eye. And every one of these layers is doing damage to the real world. They're doing nothing for it.
Mm-hmm.
They're not just blocking it, but they're causing problems with it. So a lot of this is on my blog. Yeah, here's the relative field of view. This is once again a picture from my blog, but it gives you an idea of how big they are. They're basically the width of HoloLens 2, but they're a lot taller. This is a trend we're seeing in AR, and I tend to agree with it, although I don't think, and this is just my gut feel, I kind of like the 4:3 aspect ratio. I think you want to be a little wider than you are tall. Your eyes, by the way, your eyes don't go up. So really what you want is most of the field of view to be lower, because your eyes naturally, you don't look up much. You got your forehead out there.
Yeah.
Humans are geared to look down, not up. We used to joke, the eagle, there's not too many birds of prey that can kill you. There are lots of things on the ground that can eat you, bite you, snakes, everything. So there's humans are biased to look downward. But anyway, so it makes it bigger. I do think this is a trend. We're seeing this in almost all the products.
Yeah.
There's a real trend in AR to want to be more square. I don't know how that goes. How's that doing in VR? Are you guys going more squarish?
VR, you never hear the big players talk about going wider. They're also talking about going taller as well in VR. So,
yeah, your vision is kind of circular.
mm-hmm.
So each eye, you want it, the natural. A lot of times, what you do for width is actually because you're putting the two eyes together. By the way, I highly recommend Bernard Kress' book. You get it through the SPIE. It's about $50 if you get the PDF version, and I would recommend the PDF version because you can search it. He's got all kinds of good stuff, but part of what he talks about here, there's a zone where you have stereopic vision, where both eyes are working.
Mm-hmm.
When you actually look at the vision, you can see it here better. There's this kind of zone where both eyes are in play, and there's a part of the vision which you're really you're really not, your brain and everything's not pulling it in stereo.
Right.
So there's really a zone. And what you're getting to by the time you get out here, you're covering fully the stereo zone. They say really you have to get to 30 degrees. If you're not at least 30-degree field of view, you're not really, stereo doesn't make any sense. So when people
mm-hmm.
talk 20-degree field of view stuff, usually it's monocular.
Right.
By the way, stereo is, whenever you do stereo, more than twice as hard as doing monocular, because not only do you have two of everything, but now you got to get the two to agree. You've got to worry about IPD. If you have a single one, you can look off to the side like that twos.
Mm-hmm.
Twos where they look off to the side a little bit. You cannot do that with binocular. You got to be looking, both eyes have got to be going in the same direction. These are pictures I took at the show. You can see here, you see how dark it is. It's also funny enough, I didn't see this in one other picture I'm going to show, but you notice how the color's tinted.
Yeah.
It's actually changed the tint. But this is what 20%. If you were to look from here to here, this is 20% of the light of that. They talked about doing this in an operating room. I saw the CEO on CNBC. That's what she was on. Anyway, she was talking about how operating rooms are so bright, and I'm like, yeah, damn right they're bright. They don't want them to be. They don't want to have to make them 5 times brighter again to wear this headset. They're doing it bright because they want to get into the nooks and crannies, and they want your eye pupil stopped way down. The reason you use bright light is to stop your pupil down to see well. So what's happened now, this is going to start opening your pupil up, make it harder to see the real world.
Yeah.
And we'll talk about some other aspects. But, I mean, it's a clean design. You can kind of see how small, look how small the view out is.
Mm-hmm.
And look how this is what we call it. I call these horse blinders. You see how they've got you kind of trapped in here? You're not looking out at all.
Yeah.
You can probably see out, you can see a little bit out below. You can see out below, but that's it. You don't see to the side much. And this is tight up against your face.
Right.
Like you cannot possibly put glasses on with this. By the way, that diagram before was just kind of diagrammatic. It's actually a lot more layers than that. And I've broken this down. I've done this on my blog, broken down what they're doing. A lot of these layers are associated with this thing that does the soft edge occlusion. This is the new feature they're bringing in, which is soft edge occlusion, which means you dim, but you can only control the edges softly. Hard edge occlusion is pixel for pixel. I can block the pixel. Turns out, I believe the physics are that's impossible. I think it's impossible to do hard edge occlusion optically. This is one thing the AR, VR people did, we talked about last time. They can do hard edge occlusion because all they do is substitute one pixel for another in the video stream.
Yeah.
Hard edge occlusion here means you have to bring the light of the real world into focus so you can block it. Because if I put a dot, like if you put a small speck of dirt on your glasses, you don't see it. The reason why is the light rays go around it. It goes around it, hits your lens of your cornea, and then it focuses on. But all that light went right around the blocking.
Right.
It was like putting a stick in a stream of water. The water is just going around it. So anyway, I've gone into how this dimming works, but look at all of this stuff is well, there's different things, but yeah, here you got all the dimming stuff. So you got the dimming layers. And by the way, you start with you have to polarize the light. So here's your problem. Going in, you got to polarize light. As soon as you say polarizer, you're lost 60% of your light. Plus, if you take polarizers in series, you lose about 8 to 10%. So if I took two polarizers that were polarized the same way and lined up perfectly, the first one's going to lose 60%. And everyone after that, even in the transmissive state, is going to progressively lose another 8 to 10%. And you've got some of those in here. So like these things, the way these work, remember we talked about those retarded films, quarter wave plate? Well, you can think of an LCD as kind of a variable one of those. What LCDs do and what LCOS does is changes the polarization of light.
Yep.
Changes it from linear, you start linear in and it turns it into circular polarized. You put another polarizer after it and you block it. So what they end up with is almost always in these things, you're going to have two polarizers, one on the front, one on the back. One's called they call the back polarizer the analyzer. So you have a polarizer and analyzer, and then these guys here are acting as kind of variable quarter wave plates to kind of rotate the light around to selectively decide how much you want to block the light. Well, they brag they can block like 99% of the light. The problem is they start by blocking 80% of the light. Here's another little fun fact or fun thing. I got this. This is from my own picture. You'll kind of hopefully see here. I have a better one in a minute. But you kind of see how you're getting tunnel vision here.
Yeah.
But if you look at this one real closely, you'll see that there's a diamond pattern. These are the grid. These are the powering of the individual, I'll call dimmer pixels. It's those dimmer elements. You see they're pretty dang big too.
Yeah.
Okay. Well, the problem you have, and I've done the math. I did the math for you, so you don't have to. This is a picture I caught off of CNET. I stupidly did not take quite as good a picture as they had. So I'd already done all the work and the stuff, so I'm using this one. But basically, you can see the grid. I've gone in and counted it. I've done all of the math to move, because you kind of have to say, well, how big is that at the image? There'd be about 14 by 18 diamond pixels in the area of the display. So if you take 14 into 1538 pixels, you get about 100. So if you were to look at the display, if I could bring everything into focus at the same time, there'll be about 100 display pixels inside of every one of those little diamonds. Okay, that's how inaccurate it is. So if I turn one of these on to black, it's going to affect, give or take, about 100, over 100 pixels, because the diffraction and everything. So
do you think that they might also be like rotating the display a little bit to match the diamond pattern?
No, they want them to be that way. I'll talk about why they rotate them in a minute. Once again, I've got an article that goes into great depth about this, how it works, and all the physics of it. It would take way too long to explain right now. But this is an article that's on my blog that will, if you want to know all the details of how the light blocking works and why it's soft, the basic problem, as I say, is light goes around it. And their patents even talk about this problem. So, but I've written about it. You've got two problems, though. One thing is they show, this is from their own patents, you get kind of this blurry, you don't actually block it accurately. You're blocking like 1,000 pixels. You're slightly dimming 1,000 pixels. The one you block plus the some pixels around it get dimmed. Now it's gradually getting less and less dimming because that light's going around it and all that. Now, here's the reason why they rotate it. This also comes from their patent. They have a diffraction grating.
Mm-hmm.
Light going through here is going to get diffracted, just like the diffraction grating in their lenses. And so what happens is they tend to get this pattern coming out. The reason they rotated it was to get a more, and I'm not sure if it's square. They talk in their patents about doing a wavy line and all. I don't see that in the pictures. What I see is a square grid. I think they figured that it's less worse in terms of the diffraction effects. But that's why they were talking. They have a whole patent dedicated to trying to reduce the diffraction effect. So they know it's a problem. Now the thing is, once again, we're back to demos. I didn't get to try it for that. I did get to try the dimming, and I was not allowed to take pictures. I play by the rule, but I was told I was allowed to say I got to see it. As I said, the base image quality is quite good. The dimming feature works, and the reason why you dim is because what we're doing is adding light together. We're taking light from the real world, and this is all my own simulation. This is all Photoshop. This is not to be really clear. By the way, I don't mind companies that simulate stuff because it is hard to get a picture that looks like what it does.
Mm-hmm.
I have absolutely no problem when a guy says we simulated, provided they say they simulated it.
Right.
But I do have a problem to say this is like looking at the camera through our thing, and you find out it was all a big fat lie. It was all done in post-processing. So this is simulated, to be clear. But this is kind of what it would look like without any pixel dimming. Okay, I just took something I had a 3D object of to put it up there. And this is kind of like what happens. You kind of like in the darker areas of the image, you can see it. And this is not a perfect simulation either, by the way.
Yeah.
But it just gives you the feel for it. That you get this very fuzzy. And the reason why is your eye is adding light. You're taking the light of the world and you're adding it to the light of the image you generated. You're kind of stuck with that. And so if the world is 1,000 nits and your brightness is 1,000 nits, boom. Now they have all those layers of dimming. They're blocking 20% of the light. So outside, if it's 1,000 nits, when it comes in, it's only 200 nits because they blocked 800 nits. It's been dimmed. That helps them. And then you combine it with that world. So anyway, the bottom line is you get something dim like this because the world is really bright. Matter of fact, I would bet in this world, that concrete out there, it's kind of a dark concrete. That's probably 5,000, 6,000 nits is what that concrete would be. Those bright spots on the airplane, like that spot there, that's probably 20,000 nits coming at your eye. And bright sunlight, that's probably maybe more than 20,000 nits.
Mm-hmm.
So that you can't get bright enough that wouldn't obliterate you.
Yeah.
So anyway, but let's talk about what they're doing. Okay. You kind of hopefully can see here, you can see this shadow effect. This is I think a fairly good approximation for the size and amount of shadow I saw. I was kind of intent to see how big that was, knowing I'd have to simulate it later. So that feels like about what I saw, which is, it works. It does make the thing look much more solid. But you do get this kind of shadow that moves around. A little wriggle, at least, and I don't know, I'm moving my head and everything else. But in the demo I saw, this thing kind of wriggle a little bit. But you do get this kind of ungodly shadow. Now, they do have an ability to dial this in. Like, you can dial in the amount you do it, and you can kind of dial this shadow in and out. If you want something to look pretty solid, though, you're going to get this shadow because they can't help themselves. If they don't block, if you think about it, if you want this edge to be visible, you've got to block a lot of light on either side because you have no precision. Plus, it's out of focus. This is the thing. You're not going to see a grid up there because, once again, that light is going around it. And it's being focused by your eye. The light that's up there is highly out of focus. If you give me this technology and only block 10% of the light, you got something.
Yeah.
But when you're blocking 80% of the light before you start, and that's where I take the big exception to it. It's a good idea. It's been a good idea for 30 years. People have known this or more. As long as there's been LCDs, they've known about this. That's why there's even a name for it, soft edge occlusion. Everybody knows you can do it. The problem is how do you do it and have a product or meet the needs of the user?
How
But
fast
it does
can
work.
this update, this dimming effect?
It's pretty fast. I think it's like 60. I think it's about as fast as you'd want it to do it.
Okay.
I didn't notice any problem. It did feel to me, and I didn't do an exhaustive evaluation. It did feel like it wriggled a bit, and maybe that's it, trying to keep up. That's probably about the size of pixels on a television set. When I say there's like 1,000 of these little guys in there,
Yeah.
that shows you how big TVs are. Last thing, they're still front project. Like I say, transmissivity is a big deal to me. They're still back in that low transmissivity category.
Yeah.
Where HoloLens is not great either. HoloLens, I believe, blocks 40% of the light. I think they're about 60% transmissive. Other people are really focused on it. Lumus is claiming is in the 85 range. Dispellex is claiming they're going to get to 90%. It's hard to tell the difference between 85 and 90.
Yeah.
Bird bass are really bad. They've got to be less than 25%. I don't know where Vuzix is going with their stuff. Their current stuff is probably 50% in that range, I had it 80%. Their claim is 80%. It's hard to know without all the lighting. It looks like it's less than that to me. Also depends whether they select to put tint. But I'll tell you one thing. The Dispellex is working also on this light front projection. As we've already said, the Magic Leap's still doing a lot of light front projection. This is Lumus. This is actually on. You can actually see the image in his eyeball.
Right.
Unless you get it just the right angle. And once again, that didn't have all the filters. You don't see it either. And that's like was bright. Eyeball. You can literally see the image on his eyeball. So anyway, that's kind of it there.
Thank you for coming on the show. One day is to do a live stream on the YouTube in general, and just like you had that one idea, let people ask you, why can't this work, and you shatter their dreams.
I talked to Ricky Gervais. I don't care.
Yeah.
I've got a little bit of that. I mean, I do care about the startups. I'd love to see the startups go. And I'm really, I'm kind of rooting for Tilt 5 not because of any financial or other interest. I'm rooting for them because they are working hard. They're doing things. I know hardware is hard. I've been there. So I have a lot of empathy for them, and I appreciate the energy. I'm amazed at the energy Jerry Ellsworth still puts out.
I know.
After all these years. I really get upset when big companies or people with a lot of money start lying to people or telling things that aren't true. And there's not a big upside in that. Like I say, the best case for me is somebody's trying to keep themselves from wasting $1 billion on some harebrained thing. But I'm telling you, the typical guy out there who does this thing, I don't think they want to be told it's not going to work.
Yeah.
They bring in a guy who tells them, yeah, go fever. Because like I say, as a consultant, you're kind of biased to say, yeah, let's go for it. It'll go. Because if the guy puts the money in, he probably keeps you around to keep advising him.
Yep.
Whereas if you tell him, no, don't do it, he either does it anyway and doesn't need you, or you get the one check and for helping him out and you're gone. So there's kind of this huge building bias. That's same with the Analyst. All these charts you see, all this stuff, all that's going to the moon. I mean, you kind of see it. I mean, we're seeing it now. You're seeing it with HoloLens. You see it with, things keep delaying. When was Apple supposed to be out the first time?
2019 originally.
And we'll see it'll be interesting to see what happens. Does lightweight, are people going to be willing, like in your area, VR, are people going to give up on field of view to get the smaller, lighter headsets?
We're just going to,
is that a market? Is that a market people are theorizing about? And as I said, you don't solve all the problems with AR. When you go pass through,
yeah,
that solves a problem. You were worried about one thing really bad, which is hard edge occlusion. Like I say, I think optical hard edge occlusion violates laws of physics. I think there are laws of physics that will prevent hard edge occlusion from ever working optically. So you have an impossible problem. I got a solution. I'll raise my hand. I got a solution. I will do pass-through AR.
Yeah.
And all I said is, okay, you took one off of this column and you put a whole bunch of other problems in your plate.
Yeah.
And I think we'll find that what they're going to get is a whole bunch of other problems, not the least of which is safety. If you, I don't believe I can't believe you would put a guy on a factory floor to do that. I mean, you guys have enough problem with people. Yeah, would you call it? What's the name for it when
VR
people hurt?
to ER.
VR to ER. Yeah, actually, this is funny. This is a story I heard. Even with optical AR, it's kind of dangerous. I was at a conference years ago. Reminds me of this. Docomo. It was in a Docomo booth over in Japan, and they had this thing that had like no eye box. It was a thing that swung out in front of your face, and the display was in there, and they had some optics and bringing out this little thing that came in, and you couldn't hardly see it. It's out of focus, just like Magic Leap. Anyway. It took forever. It had like no eye box. So it was like you had to have a guy fit it to your face and do all this stuff, and you could barely see it. And then they brought us over, so you spend like a time demoing. They had a whole bunch of people fitting people, and then they put you in this little corral, and that you would stand together, and they had minders minding you in this little corral to keep you from hurting yourself. And then they had TV screens that made it look like you were walking through the streets of like Tokyo.
Yeah.
And I looked at it and I said, I wonder what the average lifetime of their customer is going to be. I mean, what's your mean lifetime before you get hit by a car?
Yeah.
Because if you get focused, forgetting all the physical blocking, the attention blocking, the attention blackout, that if you're doing this stuff, there's some big issues. So I think those things are going to be hard. But I don't see how Passthrough AR solves all the world's problems.
I think the big thing with Passthrough AR coming from a VR perspective is it's giving more, at least more, it allows VR to break even more into consumer use at home, not going outside with a thing. So like, whereas VR has been only gaming, adding a few cameras to do some AR stuff, at least it's going to be way more consumer friendly than anything you're seeing on AWE's show floor for like all these optical AR stuff.
Yeah, because I'm talking to a guy, and I'll leave him nameless. I know who said it, but I'll not. But he made a good quote. He said, "You have to realize anything in AR is not just twice as hard; it's at least 10 times as hard. As soon as you make it see through, it's 10 times as hard." And I think that's really true because, as I think I've talked earlier, you with a display, if you want a big field of view and everything, it's easy. When we do it with when you want to put it in AR and make it see through, well, I can't put the display where I want to put it. I got to put the display someplace other than where I want it, and it spirals from there.
All right.
So yeah, there's just limits to what this stuff can do. There are some good uses, for all the negativity here. We've got some good technology out there to do some of these applications. Like I do see some medical uses, I see military uses, I see industrial uses. There are real uses. I think what people may do is pick up and say, you know what, I can do what HoloLens is doing, do better quality image. I can do it a lot lower cost and do that. I think that the side though, the one thing that I think is big area is going to be the detection, all the stuff for slam and locking and all. There's a lot of things to go on there where that's going to be a big thing to do. But this all singing, all dancing, just because it's Apple, I think you're going to find out that Apple, as I sometimes say, Apple has the same laws of physics as everyone else, and so they get. Look, Meta spent, I think, what they spent somewhere in the neighborhood of $20 billion plus. At least 4 Magic Leaps.
Yeah.
Okay, because that's my unit of AR spending. Sorry, almost 7 Magic Leaps. And yet they're still not out. They're still delaying. They're still not landing. I think the problem is when you bring that plane down to land and they say you spent $20 billion to do that.
Yeah.
And is it going to be another $20 billion? And what you find out, as I said, sometimes that $20 billion, the next step is another $20 billion. And it's not getting you to Valhalla land. That's just getting you to the next step.
One thing I just want to finish off of is like kind of crossroading what you're saying about the SLAM stuff is you mentioned that Omnivision is the one making the LCOS for Magic Leap. And the one funny thing about them is they make all the SLAM cameras for all the Meta devices. So just a lot of crossroading in the industry, and things are going somewhere at least with these companies.
Yeah, I think they bought into LCOS a long time ago. They bought a company called Aurora Systems. And I think they were kind of expanding out. They were trying to hedge their bets against the where would the camera business go? Would it keep going down? But cameras have gotten really cheap. It turns out, and I sometimes say this thing, that some technologies are kind of like rolling downhill and some technologies are pushing uphill.
Yeah.
Turned out the cameras were sort of rolling downhill. They got the volume going, but they also don't have to carry in the first surface, a camera sounds harder than a display. But the display does not have to generate light.
Yeah.
The camera does not have to generate light. The camera just takes the light in. And it turned out that was technologically a lot easier to keep making that smaller and cheaper than it was to make the things that have to generate light smaller and cheaper. I got my glasses. Everyone draws the glasses up there and says, well, where are you going to put the cameras? Don't you want to, if you really want to do good recognition and good slam, don't you want to put those cameras, kind of spread them out a bit? So now all of a sudden I got big glasses, right? And, and then I got to power them and I got to transmit it. And that's my thing is that I don't really consider it to be, for most purposes, that useful as long as it's got a cord. I think cords are just too dangerous.
Yeah.
So the first thing you're going to do is you got to get rid of the cord. So now it's a self-contained system. You may be wirelessly communicating. And by the way, that gets to be a serious problem too. Just photons, photons to motion, right?
Yeah.
How long is it going to take from something happening that gets, something happens, boom, 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 and round trips back by the time you process it and everything. This is why 5G doesn't solve it. Man, funny how 5G's gone away. It used to be an AR a couple of years ago. Everything was 5G. They've solved their processing problem. We're just going to transmit everything via 5G in real time with no delay. We're going to transmit it. And I'm kind of, well, the speed of light is a foot a nanosecond. So that's a little problem right there. That thing better not be too many feet away, because you got to round trip it. By the way, that means for every foot away, you're 2 nanoseconds, one in and out. That's just the transmit. That's just speed of light transmit speed. So that tower better not be very far away. That computer better be sitting on you, because there better be a compute at that. You're certainly not going to ship it. You can't ship the job off to someplace halfway around the world on the internet.
Yeah.
You get the computer's got to be at the 5G node, and you're going to have that much horsepower at the 5G node. What if 10 guys with their headset walk in one day? All of a sudden, everybody. You get this. By the way, this is a problem you have when you go to the show floors and places. Your phone stops working because there's too many guys dinging on the cell.
Yeah.
Right. Particularly at times of day, you can see it at like CES and places. There's certain times of day when everyone's on their phone and cell phone service just goes to hell.
Yeah.
What's going to happen if everyone's trying to tie up the computer at a node that's close enough so that these things aren't tied down? I put this challenge out there. Get somebody for the 4Ks, or get 5 guys. I'll take 5 on 1 if you want, because I got the easier problem. Is say, how are you going to solve this problem without having to wave your hands and say 5G? I always call it the Moore's Law and Steve Jobs. Steve Jobs is a saint now, and Moore's Law means that you just wave your hands and everything's solved. I'm kind of like, how are you going to do this? Like I say, hard edge occlusion, right there, hard edge occlusion. I don't think it's possible. And so there's problems like that nobody knows how to solve. And you have, I've seen guys, I even think there are people who should know, who I think know better, who said that they can do it, that it just takes more work. And I think there's some problems you have to recognize. There's some physics problems that just turn the crank doesn't solve.